All right, for this lesson, we're building off SOHCAHTOA. So you want to make sure you remember that. You'll be using this throughout the entire chapter, okay? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA. Tangent is opposite over adjacent. Okay, so we'll use that for this lesson as well. And when you see it on a calculator, you'll see sine instead of sine with an E. You'll see that the E isn't there. And instead of cosine, you'll just see COS. And instead of tangent, you'll see TAN. So you'll see the abbreviations. And that's what we'll use as well when we're writing ours. So if we remember our reference angle, so we're going to use A as our reference angle. And we can use A as a reference angle, or we can use this angle. We can name that B. But you can't use the right angle as a reference angle, okay? So just for the sake of this one, we're going to use A. But just remember, you can't use the right angle as a reference angle. So we have the sine of A is opposite, and we're talking about the angle, so I'm going to make sure I write that symbol as well. Sine of angle A, because we are looking at a reference angle, which is our A in this case. And that's going to be opposite over hypotenuse, and that's A over C. If I look at my cosine of the angle A, that's adjacent. Remember, adjacent means that it's next to, and it does touch that angle. So it has to be the side that touches the reference angle. And that's adjacent over hypotenuse. Your hypotenuse does not change even if your reference angle changes. So that's going to be B over C. And then the last one, our tangent of angle A is opposite over adjacent, which is A over B. So that we'll still use for this lesson, we'll use for the rest of the chapter. So again, I already mentioned this, but remember that with trigonometric ratios, your reference angle can be either one, but it cannot be the right angle, and it says that right here. Not the right angle. You can write trigonometry ratios from either of the angles that are not the right angle, which is angle A or B in the picture. And angle B wasn't labeled, but go ahead and label it. That's angle B. All right, let's start with number 1. Based on the given trigonometric ratios, sketch a triangle and find a possible value for the missing side as well as the other missing trig ratios. Angles A and B are the two non-right angles in a right triangle. So we're going to go backwards. We're going to start with the information that is given, and which is a ratio. In this case, it's that one. And then we're going to figure out what our triangle is, what sides are which, like where's the 5, where's the 10. And then we're going to figure out the other trigonometric ratios based off of that. So if I label this, that's going to be my right angle. The A and the B, it doesn't really matter where you put them, because we have to make sure we look at our reference angle. In this case, since we don't have anything here, we have to figure all this out. I already mentioned it, but we have to use sine of B to help us out. That's the only one that's given. And that's 5 over 10. So remember sine, if I remember from up here, the sine is opposite over hypotenuse. But instead of A, we're using B as a reference angle. So that's our reference angle. And remember, it's opposite over hypotenuse. So that means that this is my opposite. 5 is opposite, and the 10 is the hypotenuse. So we have to figure out what this is right here, what that side is. And since it's a right triangle, we can use the Pythagorean theorem. The only thing you have to be careful with when you're plugging it in is your C value has to be your hypotenuse. The A and the B you can switch, but your C value has to be the hypotenuse. So I'm going to go ahead and plug everything in. So 5 squared, doesn't matter if I put it in for A or B, but the 10 has to be the C because that's your hypotenuse. It's directly across from the right angle. So I've got 25 plus B squared equals 100. And I'm going to get B squared equals 75, if I subtract 25 from both sides. And then I'm going to take the square root. B equals the square root of 75. And you want to make sure you reduce that all the way. So 75, think about quarters. You have 3 times 25. And then that 25 is a perfect square. 5 times 5 is 25. So I'm going to have 5 on the outside because I have a group of 2. Root 3, that's my missing side right here. And now I can figure out what my other ratios are. So tangent of A, if we go back, we're going back and we're using a different reference angle. So just for the sake of this, let's use our reference angle B first. So let's do these first, and then we'll go to A. So tangent is going to be TOA, right? So opposite over adjacent. And then cosine is ca, adjacent over hypotenuse. And I'm going to keep the same reference angle, and then I'll switch it to A, and you'll see the difference. So for that one, opposite is 5 for tangent of B. Adjacent is 5 over square root of 3. We just found that out. And if you notice, you're going to get 5 over 5. So those are going to cancel out. And I'm left with 1 over the square root of 3. 5 over 10 for E, you can reduce that to 1 over 2. I don't want to reduce it before, because if I reduce it before, then you're going to change the sides, and the sides are 5 over 10. So if it asks you to reduce all the way, you might just want to leave it as a decimal. That's 0.5. But you can also just leave it alone. Cosine of B, so that's going to be adjacent. So what's adjacent to B is 5 root 3. And then what's the hypotenuse? Well, that's 10. And 5 over 10 does reduce, just like it did for E, to 1/2. So I get square root of 3 over 2. And now we can change our reference angle. Now I'm going to change it to A. So now my reference angle is A. And I'm going to find the same things. So the tangent of A is opposite or adjacent. So what's opposite? It's 5 over 3. Sorry, not 5 over 3. 5 root 3. What's adjacent? That's going to be 5. And that reduces to, these cancel out to just the square root of 3. And notice that that's the reciprocal of D. So this is the square root of 3. This is 1 over the square root of 3. Those are reciprocals of each other. If I were to just put that over 1, because the square root of 3 is the same thing as the square root of 3 over 1. And you should notice that those are reciprocals of each other. Sine of A, is opposite over hypotenuse. So the opposite of A, opposite side is 5 root 3, and the hypotenuse is 10. So that reduces. The 5 over 10 cancels, or sorry, not cancels, but reduces to square root of 3 over 2. And notice that that's the same as cosine of B. And then you've got the cosine of A, which is adjacent over hypotenuse. So that's 5 over 10. And that's the same as the sine of B. All right, moving on. We're going to find the missing side lengths using trigonometry ratios, and your calculator is going to find the trigonometry ratios of the angle. So all you're going to do is on your calculator, you're going to find the sine of 62. Sorry, just the sine. You're going to find this button. So sine on your calculator, and then press 62, and then your enter button. And if you do that, you're going to get more than 2 decimals. But let's just round it to 2 decimals for the sake. For number 3, you would do the same thing, but this time you're finding cosine. Find that button on your calculator, then press 15, and then press enter, and you should get 0.97. So what this is doing is the calculator is finding those ratios, but it's finding them in decimal form. So if we come back here, like 5 over 10 is 0.5, right? So that is, that's in decimal form instead of fraction form, and the calculator is putting it in a decimal form. So this is a decimal, but it's telling you, instead of a ratio, it's telling you the decimal form of it. And then you're going to find your tangent button. Remember, it's just going to say tangent. So find that button, press 78, and then press equals. And you're going to get 4.7 for this one. So it's okay that it's bigger than 1, because that just means that if you have it in a fraction form, then your numerator is bigger than your denominator. So again, these are just using your calculator. You'll need a scientific calculator for that. All right, for the last portion of this, you can use the trigonometry ratios, sine, cosine, and tangent to help find the missing sides in a right triangle if you don't have enough information to use the Pythagorean theorem. So remember, the Pythagorean theorem is a squared plus b squared equals c squared. But in this case, we don't have enough information to use it. So we're going to have to use sine, tangent, and cosine to help us figure out what the missing side is. So you will be using this SOHCAHTOA to help you out. All right, so if we look at this right here, number 1, you're given 57 degrees. You don't know what this is. You could figure it out, but you don't really need it. So use whatever angle they're giving you. So this is going to be my reference angle. So just like before, we had reference angle A or reference angle B. This time, instead of just calling it A or B, it's 57 degrees. So we have, what do we have here? We have the opposite side. So X is the opposite side. And we also have 25, which is the hypotenuse. So that means you've got to look at SOHCAHTOA and see, like, which one am I going to use? Am I going to use sine, cosine, or tangent? Well, I've got an O and I've got an H. So I'm going to use sine. So instead of writing sine of A or sine of B, we're going to write sine of 57. And that's going to be opposite over hypotenuse. So X over 25. And we're going to be able to solve for X. So what we're going to do is we're going to multiply both sides by 25. And then what happens is on the right side, these cancel out because you're multiplying 25. You got it on the numerator and you've got it on the denominator. So I just get x. And x equals 25 times sine of 57. So what you're going to do is on your calculator, you're going to press 25 first. Well, that might depend on your calculator, but find your sine button and then 57. So you might have to do the sine first, or you might have to do the 25. That depends on what type of calculator you have. But basically you have 25 times the sine of 57 degrees, and that's going to give you a decimal. That's going to give you a number, and you want to just make sure you round it. And in this case, let's just round to 21 because we're going to the nearest tenth. So for this, what do you get? 20.9667, and it keeps going, but we're just going to go ahead and round that. So I'm going to put the little squiggly equal sign to 21. And that's how you use sine, cosine, and tangent to find a missing side when you're not able to use the Pythagorean theorem. So let's go ahead and try number 2 now. So let's look. We have 35 is going to be our reference angle. So that's 35. And again, instead of writing sine A, sine B, or cosine A, cosine B, you're going to just write 35. You have an actual angle now instead of just having a variable like A or B. So let's look at what we have. We have opposite. So we have the opposite side we know, and we also know the adjacent side. We don't know what the hypotenuse is, so we don't need that. But if you've got an O and you've got an A, you're going to have to use tangent. So that means I'm using the tangent of 35 degrees because, again, we don't need to use A or B. We have the actual angle. And the opposite side is 9. So it's TOA, so 9 over y. And, we want to get the y by itself. So what we're going to do is we're going to have to multiply both sides by y here. So times y, and then times y on the left as well. And we're going to have to do this to rearrange the equation a little bit. Those cancel out. We get y tangent of 35 equals 9. And then we can go ahead and divide both sides by the tangent of 35. So on your calculator, you want to do 9 divided by, and then tangent of 35. And we're rounding to the nearest tenth. So you should get about, y is about 12.9. And that's how you find a missing side on a right triangle when you can't use the Pythagorean theorem, by using sine, cosine, and tangent. And you're going to go ahead and do some practice problems on your own now.